Today, we are going to pull back the curtain on a hidden property of water. It's something that affects pretty much everything, from your morning shower all the way up to giant industrial power plants. You can't see it, but trust me, you can feel its effects. Let's dive in.
You know that feeling, right? You're in the shower, you're trying to work up a good lather with your soap or shampoo, but nothing. You just can't get those rich, satisfying suds no matter how much you use. It feels like the soap is just vanishing. Well, it's not you, and it's not the soap.
The real difference is in the water itself. See, with soft water, you get that perfect foamy lather we all love. But with hard water, well, it's a different story. It actually fights against the soap, leaving behind that gross, sticky gunk we call soap scum.
So this little everyday frustration is actually a fascinating chemical mystery. We're going to explore the science that's happening right there in your own sink. And you'll see how this one little thing connects to some much bigger issues.
That's right. The reason for all your troubles, the latherless showers, the scummy sinks, it's all caused by something you can't even see. It's dissolved, hiding in plain sight, right there in your water.
All right, let's decode this thing. What is this invisible culprit? We're talking about a property called water hardness.
So what is water hardness? In a nutshell, it's a property caused by dissolved minerals, specifically calcium and magnesium ions. These are the little troublemakers that react with your soap to create that insoluble scum instead of a nice, clean lather.
And where does this stuff come from? Well, most of the time, it's totally natural. As water travels through the ground, it flows over and through rocks like limestone, and it just picks up these tiny calcium and magnesium particles along the way. But unfortunately, it can also come from industrial pollution. Now, here's where it gets interesting. Not all hardness is the same. There are actually two different kinds. First, you've got temporary hardness. This is caused by bicarbonates, and like the name says, it's temporary. You can actually get rid of it just by boiling the water. You know that chalky scale that builds up in your kettle? Yep, that's temporary hardness coming out of the water. Then you have permanent hardness. This stuff is caused by sulfates and chlorides, and it is way tougher. Boiling does absolutely nothing to it. You need special chemical treatments to get it out.
So when scientists want to figure out the total hardness of a water sample, they're just adding those two types together. It's a really simple equation that gives them the complete picture of what's going on with the water.
Okay, so if these minerals are totally invisible, how on earth do you measure them? Well, this is where some seriously clever chemistry comes into play, with a process called titration. Let's break down how it works.
The hero of this entire process is a molecule with a super long name, so everybody just calls it EDTA. And the best way to think of it is like a tiny chemical claw. It is incredibly good at doing one thing and one thing only, grabbing onto those calcium and magnesium ions.
The whole process is actually pretty cool to watch. First, you take a water sample and add a special indicator that turns the water a wine red color. Then, you start slowly dripping the EDTA solution in. As you add it, those little chemical claws get to work, grabbing all the hardness ions. And once every last ion has been snatched up by the EDTA, the indicator is finally free, and bam, the water instantly changes color to this brilliant sky blue. By measuring exactly how much EDTA it took to make that happen, scientists know precisely how hard the water is.
So why is this the go-to method for testing water? Well, it just checks all the boxes. The EDTA method is super accurate, it's fast, and it's cheap. It's just way more reliable than any of the older methods, which is why it gives scientists the exact data they need.
So far, we've talked about soap scum in your shower and a little bit of scale in your kettle. Annoying? Sure. But now, let's scale this problem way, way up. Because in the industrial world, hard water isn't just an annoyance. It's a massive, multi-million-dollar headache.
Yeah, we're talking about way more than soap scum here. This is about serious physical damage to incredibly critical and expensive equipment. The same process that clogs up your kettle can literally bring an entire factory to a grinding halt.
It's kind of a chain reaction. First, that scale builds up inside huge industrial boilers, and it acts like a layer of insulation. This makes the system work way harder, burning more fuel, which can lead to overheating. That scale also causes corrosion that literally eats away at metal pipes, and that can lead to leaks, catastrophic failures, and incredibly expensive shutdown.
You can really see the impact this has over time. As that scale builds up, the energy efficiency of a system just plummets. What starts as a tiny loss after just 1 month becomes a huge drain on resources and money within a year,
It drives up costs and seriously increases the risk of a major failure.
And this is exactly why managing and regulating water hardness is so important. You can't just let it run wild. There are entire systems and standards in place specifically to tame it.
To protect all of us and to protect our industrial infrastructure, water quality is watched like a hawk. It's carefully monitored and measured against a whole set of established international standards.
So who are the rule makers? Well, you've got the big global and national players, like the World Health Organization, the U.S. Environmental Protection Agency, and the Bureau of Indian Standards, just to name a few. They all publish these super detailed guidelines on what makes water safe and usable.
And to give you a concrete example, let's look at one key number from the Bureau of Indian Standards. They say that for safe drinking water, the total amount of all dissolved solids, which of course includes the hardness minerals, has to be less than 500 milligrams per liter. That's it. It's a clear, measurable line in the sand.
So how does your water stack up? These are basically the official grades. If your water is under 50 milligrams per liter, you've got soft water. But once you get up past 300, you are officially in very hard water territory. And at that point, you are definitely going to have some trouble with your soap.
You know, it all started with a simple question about soap. But as we've seen, the answer reveals this entire invisible chemistry that affects our homes, our industries, even our health. It really makes you stop and think, what other invisible forces are out there, quietly shaping our world every single day?